Thank you for joining us for our second SEL Interdisciplinary Research Center seminar for 2021. Today's lecture is the second installment of our four-part seminar series co-hosted with O9 Solutions. Today we have Ripu Daman Singh, Vice President in Product Management and Marketing with O9 Solutions, joining us from Dallas, Texas. Our moderator for the session is Tim Brown, Managing Director for the Supply Chain and Logistics Institute.
Thank you, Andy. I think Andy covered most of the important points. This session I'd call out is focused on operational planning, particularly sales and operations execution, with a focus on the control tower space. We very much like to thank O9 for participating and sharing your technologies and thoughts on emerging technologies being applied in various levels of supply chain planning, from strategic, tactical, and operational. And we particularly like to welcome our grad students, faculty, and industry partners today. And just a little bit about the background of our today's speaker, Ripu Daman Singh. He's the Vice President of Product Management and Marketing at O9 Solutions, and he has a history of over 20 years of experience in the supply chain planning software solutions development space. And over the years, he's worked in a wide range of industries, so he's seen a number of problems and developed techniques to address them. Ripu Daman holds a PhD in operations research and industrial engineering from Penn State University. And so without further ado, we'll turn it over to Ripu Daman. Thank you.
Thank you, Tim. Thank you, Andy. Very happy to be here. Welcome, everyone. This is the second seminar from O9 in this series. Today's agenda, very briefly, I will provide a very brief introduction on O9. Umesh in the last seminar has already done that, so I'll be very brief. And I'll then get into the meat of the discussion today, which is the SNOE control tower. SNOE stands for Sales and Operations Execution. I'll then touch upon the current state of reality that our customers actually tell us about. And then we'll get into the use cases, the forward-looking direction. And I'll actually, at this point, illustrate those use cases with the product itself. So we'll get into the product. The idea being to understand how the control tower and the sales and operations execution space works, how decisions are made. And then in the closing section, we will talk about the value prop, okay? And then just keep typing in questions as the talk continues. And we hopefully will have a free forum in the end for the Q&A where we can interact and make it interesting. All right. So let me give a very, very brief introduction on O9. So O9 is a software company. We aspire to be the digital brain for global enterprises, for business decision making. We actually have an integrated business planning platform on which we build supply chain planning, revenue planning, financial planning, commercial planning software. And we hope to be on the journey of the digital transformation for our customers. So we are very active, obviously, in the industry, and we have our presence in almost all industry verticals. And this is a smattering of some of our customers, and you can see many industry leaders are part of our ecosystem, and we are happy to be enabling them and getting them ready for their digital transformations. The digital platform that we are talking about, just a couple of minutes on it. It's actually a GraphQL-based platform, if you will. So that means it's able to represent the complex relationships, the networks that exist in businesses, and it is also able to aggregate the information at each node. What does it that enables us to do is it helps us to plan and execute at various levels of abstractions of the supply chain. So that becomes a very powerful thing that we provide to our customers. What we also have is obviously our platform is AI first platform. So we have the whole framework to develop machine learning algorithms from development to production. So we have various plugins that we provide out of the box, as well as plugins that can be constructed by our customers themselves. And we have a very rich UI infrastructure as well. So right from the conception to delivery, all the aspects that are needed for software development are part of our platform. We are a global company and headquartered in Dallas. That's where I'm based out of. But we have presence in almost all continents, and we are recognized as in the visionary quadrant of Gartner. Okay, so that was a very brief introduction. You can always go to our website for more information, or reach out to any of us. We'll be more than happy to talk about it further. So with that, let me get into the meat of the discussion today, which is what is meant by an SNOE control tower. Okay. Now, over the last 5 to 10 years in the space of supply chain planning, right, and execution, control tower, the word has been tossed about. It has meant many, many things. Unfortunately, in its history, it boiled down to providing visibility into what's happening in the supply chain. And that visibility was also kind of backward looking. So you knew what had happened, and based on that, you would generate some kind of reports. While the insights are very valuable, they are not forward looking, and they lack actually the ability to make the decisions actionable. If at all you can make decisions, then how do you actually make those decisions actionable? So it was a very limited view. From O9's perspective, our worldview is much more broader. So we tie it into the SNOE space itself. If you think about it, SNOP, that Sales and Operations Planning, it happens at a monthly heartbeat typically, right? And you are forecasting, so you're doing demand planning at a monthly or a weekly heartbeat. And then you're doing master planning, which is typically on a weekly heartbeat, right? That's basically what's happening. However, reality unfolds, right? And when reality unfolds, it unfolds in a different way than what you assumed it to be when you had planned for it. So within this weekly plan and monthly plan, if you will, as reality unfolds, there are perturbations in the supply chain, in both on the supply and the demand side. So the supply side perturbations typically are disruptions, right? So this could be both material or capacity disruptions. And on the demand side, the demand can fluctuate, right? It can go up and down. So when it is up, you have an opportunity that has presented itself. And when it goes down, then, obviously there are other repercussions. So the key then becomes that if these perturbations are happening in the supply chain during the week, do you wait till the end of the week, the start of the next planning cycle, to even become aware of it? And not only just become aware of it, understand how to react to it? No, you don't want to do that. You want to understand as and when, as early as possible, that these changes are happening in your supply chain. You need to understand what are the impact, of those changes. So that's basically the translate section. You got to translate it into the risk and opportunities that are presenting itself, right? So if there is supply is delayed, then at the end of the day, it is affecting your customer. That's the translation of it, right? So your demand is getting affected, your revenue, your margin, your market share can get affected, right? And then you need to take that and say, okay, how do I solve for it? And so basically, how do I get around the disturbances that have happened, and how do I capitalize on the opportunity that has presented itself, right? So you minimize your risk and capitalize on the opportunities. So most of this, mind you, is happening within the week. So this is kind of like daily, hourly decision making that we are talking about, which essentially means that you do not have a lot of time to dwell upon a lot of decisions that you are making as well. So the decision making, the intelligence to make the decision has to be embedded in the software itself so that automated decision making can happen. And only the exceptions, and I must underscore that, only the exceptions that cannot be handled in, or rather have been explicitly modeled that, hey, we need approval for these, those are presented to the user that, okay, go ahead and can you look at these and approve these, and thus the decision making happens. Once the decisions have been made, you want to promote it to execution. So all the execution systems, will be aware of those decisions. And then what we do is in our post game, we try to learn from that so that we understand that the decisions that are made, how good and effective they were, and should we replicate them in the future or not. Okay. If I was to summarize all this that I said, right, I would probably summarize it in 3 questions, right? What is likely to happen? That's the first question. So you are here now and you're looking into the future and you are saying, okay, I am seeing the inputs have changed and I see what my future demand looks like, right? I've seen my supply change. I've seen my capacity change. I've seen what my demand looks like. How do I predict what needs to happen from now on, right? Then the second question would be, okay, the supply that I'm getting right now is not that reliable, or the demand is also not, that stable. So it's possible that it might change. How can I figure out that if those changes happen, what should I do, right? Or if there are changes that are already happening, I may have an option A, B, or C. I need to evaluate those options and see which one is better for me to proceed forward with. So those are the prescriptive insights, what actions to take, right? And then in my post game, that's the yellow box on the left, I need to understand how did indeed reality unfold? How did I perform, and learn from how the delta between my decision making and the reality that had happened, right? So that I can apply it in future decision making. So those are the 3 questions I would say that we should always keep in mind when we make decisions. There's another way to look at it, and this is basically coming from a very practical experience, right, of the maturity of various companies, right? So we have 3 aspects of the control tower, if you will, that come together to create a control tower. So one is, you can call it as daily operations planning. So this is, understanding all the demands that have materialized, supplies that have materialized, and doing a supply-demand match, and highlighting what has changed and why it has changed, and be able to come up with the delta plans and push it out. So those plans are basically your production plans and procurement plans, distribution plans, order commitments, all of those, right? So you already have those, but on a daily basis, you update it. What you are doing is you are, in the next bucket, you are trying to provide a continuous visibility during the week, during the day, right? On a continuous basis, that this is what my supply chain picture looks like. Right? This is where my inventory is. This is where it is headed. These are what my orders are. These are the alerts that have come into the system. This is the revenue that is at risk. This is the aged inventory that I am, that is tied up in places where I can't move it. All of those things you are continuously trying to monitor. And as the changes happen, you are trying to continuously plan for them. That's your intra-day replanning. Okay. And then the last bucket is putting all of this in context of the fact that you are trying to achieve street objectives, right? So in your SNOP, you have figured out your revenue objective, your margin objective, your market objective, your cost objective, that is, you have to keep costs under control, right? So, but when reality unfolds and you're making a decision to expedite or do alternate sourcing or whatever else, there is additional money involved in that, right? You have to spend money to expedite. If you are doing that, then it is affecting your margins, obviously. It is affecting your budget. But if you don't do that, then you are losing revenue, right? So you have to track and make decisions in context of what has been set as the goals and the targets for the quarter, right? Plus, you want to keep a very close eye on various initiatives that are there in your, that the company is working towards. So, for example, you may be having a very hot promotion going on. You may have a product launch initiative that is going on. So there are various initiatives that you need to track and make sure that that is indeed tracking to the targets that you had set. Plus, you want to monitor your key partners, right? Those will be your customers, your suppliers, your manufacturers, your distributors, and you need to keep track of them, of all of them, as to how they are performing and if they need your urgent attention. Okay. So with that, let me kind of present a pictorial very quickly, just to drive home the point that how reality changes, right? So your typical supply chain has, say, 4 stages. You have your suppliers from where you buy your material. It typically comes into your plants where you manufacture, then you move it all the way to your distribution centers and to your customers. And the customers is where obviously the orders are coming in, and that's the one role that you are geared to satisfy, right? Everything else is a cost center. Your customer is the only profit center. So you are taking care of your customer to ensure that the orders that they are placing on you are actually being met. Now, but as I told you, if you are buying, there are POs that you execute to. But those POs, the commitments may change against those POs. If they are shipped, then they may be shipped late, or they may get late on route to you, right? Oh, you need to track that and understand that those changes are happening, even predict that these changes may happen. In manufacturing, similarly, you would have production orders that may be getting late. The WIPs, you need to know the WIP positions. Your capacities, you may be having the plant shut down or a line shut down, the machine broke down, whatever it is, which affects the manufacturing. The movement from the plant through the DCs to the customer, right? So all that is based on the distribution network, the trucks that are moving the goods around. So there are stock transfer orders associated with that, tracking them. And obviously, you have changes to the sales order where new orders can come in, old orders can get reduced or canceled. And so basically what you are doing there is then you're trying to make decisions to counter each one of these, right? You may be expediting your POs. You may run an extra shift to cover for the lost, maybe down the line when it went down. You may have to run an extra shift to do that. You may be expediting, your route, or you may be sourcing from an alternate DC. At the end of the day, you may even try to shape demand to your customer so that you can support the demand that is existing out there. But in this whole view, what you're trying to do is you're providing for an end-to-end visibility. This is not a static visibility. This is not just saying this is the inventory sitting here. You are actually providing a dynamic view of the inventory. Of the goods throughout, whether it is inventory, movement, production, order fulfillment, all of that, a dynamic view. Where you are, where you think it's going to head, all of that is included in the visibility, right? You are able to provide alerts so that when the user interacts, whether it's a material manager, a procurement manager, a production planner, a customer service representative, whichever role is interacting, they understand what to focus on in a prioritized way, right? They are able to understand the impact analysis. If there was a PO delay, the production order can get delayed, the STO can get delayed, and the end customer's order can get affected. So there is a chain of a reaction chain, if you will, that exists. So that impact has to be very clear and translated into business terms. It really doesn't mean much to say that, oh yeah, my production, will be delayed by a day, right? But when you put dollarized values, and tie it to your SNOP targets, then it becomes much more meaningful, right? So, and then obviously suggesting solutions, automated and manual, as to how to solve those problems. Okay. So, like I said, so at this point in time, let me go back to the process side of things, right? So I think so it's very clear as to what happens in the supply chain, as reality unfolds, and how Control Tower is trying to provide visibility and control on it. But I had talked about the SNOP process, the master planning process, the demand planning process, and how Control Tower fits in with it, right? So this is to reinforce that from a process perspective, you have demand planning, which is monthly or weekly, master planning, which is monthly or weekly, and SNOP, which is typically monthly with weekly checks on what's happening, right? But then you enter the operational planning zone, the SNOE zone, which is where the Control Tower plays the role. So this is where you are trying to ensure that your orders are getting satisfied according to the allocations you have for them. You are trying to interact with the factory to make sure that the schedules that they are creating you are influencing the schedules and understanding what whips are there in the factory. You are able to interact with the transportation execution systems to give them the needs so that distribution planning, the movement of trucks can happen, and you are getting the feeds back in terms of the STOs and the in-transit as to where the things are. And similarly for procurement plans, the master planning would have already created the POs that are getting cut. Here you are monitoring how those POs are progressing. Are they good enough or not? Do you need to cut expedited POs? All of that will happen in the Control Tower, right? So this is, by the way, the master planning process in a little bit more detail. So you see that you have your demand forecast flowing in, you do the netting, you understand what your cycle over cycle changes are, you generate the plan, you analyze it, you interact with other stakeholders that you have, right, to come up with the plan. You run based on those inputs, you are running a constraint plan, and then you are ready, you're trying to get yourself ready for the SNOP meeting, which essentially what you're doing out here is an iterative development of the plan, which is saying that, okay, if my supply, the various decisions that you are making with your partners, you do it in an iterative manner to come up with a plan that you ultimately then present for approval to the SNOP executives. Now, digging it into a little bit more detail is where the Control Tower process then comes in, post master planning, that you are getting all of those feeds in, the latest sales orders, the latest inventory pictures, the supply pictures, the in-transits, all that is coming. And you are automatically doing the analysis from the previous cycle. You are generating the plan, and you are able to, across the role, understand the plan and try to publish the updates that are there. But as the various change events happen, you try to accommodate them and make a decision. You evaluate them, come up with auto resolutions, and make a decision whether to promote to production, or you have informed the stakeholders and they will be incorporated in the next run. Okay, so that's very briefly how, if you will, the process, the three processes, or the whole process from the SNOP master planning all the way to the Control Tower unfolds. Okay. Now, all this is well and good, right? But when we go to our customers or prospects, right, we hit a different reality. And that's the reason they approach us and say, hey, come in and help us move away from this nightmarish reality to where, they want to go. So when typically we see them, right, there is a huge gap between what they have planned for and what the execution is, right? So typically they are missing their revenue and margin targets. Why? Because the plants have capacity issues. The suppliers have are shipping shipments late to them or changing commitments for them. The DCs may be running out of capacity or receiving bays and so on and so forth. And the obviously the customers are maybe dropping in orders which are unexpected and unfortunately go unsatisfied. All of this is happening and they have no control over how to solve for it. So how do they solve for it? They basically don't even get into this meeting that is depicted in this PowerPoint, right? They all are actually acting independently in their own silos. And they literally have very little communication to know that if I'm making a decision on one side, what is the effect of that decision on the other side? So this is unfortunately the state of reality. The key here is they come to know of that the reality has unfolded differently too late, right? They do come to know, obviously, when they miss their targets. But the point is that they should have known about it earlier and as early as possible. The second thing that we see in our customers is that they have made some assumptions in planning, right? So if they have made those assumptions, the assumptions change, right? You can't be inflexible when you do planning. You need to understand that if there is, let's say I have assumed lead times. I have lead times, for my suppliers to ship to me, for transporters to ship from a DC to another DC or to the customer. My production itself has certain lead times, right? And if I've assumed those lead times and I assume that they will remain the same, I'm making a big mistake. Why? Because maybe these lead times actually change according to the season. Maybe they are not as uniform as we think they are, and on each lane, by season, by item, by event, right? It changes. So if you have a port congestion event, you have maybe a storm coming or whatever else, these lead times can change. So there has to be a perspective on what the latest assumptions behind the supply chain are. This can go on to, for example, the yields and the resource consumptions, the recipes even. So a lot of times the recipes to make things change. This is very true in process industry. So they can actually substitute a kind of potato chip with another kind of potato chip, for example. And those, if they are making changes to the recipe and they are not informing the planning systems that the recipes have changed, better still to say that you are not able to detect that these recipes have changed, so that you should be able to say that I'm not seeing a consumed per of 5 per unit produced. I'm actually seeing a consumed per of 7, right? You should be able to challenge these assumptions. So we see they are not challenging that at all, right? They are not questioning the reliability of the partners and the demand itself, right? So typically what you do is you have variability, and the variability you incorporate both demand and supply. You incorporate in the multi-echelon inventory planning, and that's how you get your safety stock levels in master planning and order planning control tower. So that is from a statistical perspective, you say store this much to buffer against the variability. Now, obviously, real world is random, right? It's according to the uniform distribution that we, the distribution, whichever distribution, that is there, but it is a random process within that distribution, which means that Right now, I may be running low. I may not have enough stock for my safety stock, right? And therefore, I will have, if there's a new order that has dropped in, I may not be able to meet it, right? So while I try to buffer against this through keeping the appropriate buffers, the randomness of the process at an execution time behooves me to say that how do I understand and comprehend that the new order that came in, how reliable is it? Or the partner that is saying that I am going to ship you the supply, is this partner actually going to ship me the supply, or there is a serious chance that it will get late? I need to have an understanding of that fact, okay, from an operational execution reality perspective. Then there is latency in receiving the information. Essentially, what's happening is that the information is with your partners, and they are not telling you that this is what is going to happen. So if they're shipping the material late, they're not informing you that it is shipping late, right? So you have to therefore have sensors to understand that, hey, this shipment is going to go late. You have to have that intelligence built into the system. So that is true at all levels of your supply chain. Okay, so there is real latency in receiving information. And mind you, the earlier you know about the fact that things are not executing according to what you thought it should, the better you can utilize, you can make decisions and utilize that opportunity, that time period opportunity that has presented itself to maybe trigger on other playbooks. And the final thing is the information inside the organization itself is siloed. Okay, this is a big deal, and that is why we have invested so heavily in the digital platform itself. Where is this information stuck? It's stuck, believe it or not, in Excel spreadsheets, local databases, PowerPoints. This is where it is stuck. A lot of your multi-billion-dollar enterprises are run on the basis of Excel spreadsheets. And obviously, there is, the decision making. There will be coordination issues, assumption issues. Information will be hidden from one stakeholder versus another stakeholder. This is not how enterprises should be run. So, but when you are able to capture this information in the enterprise knowledge graph, then suddenly you see that these silos start getting broken. So those are the four key things that I wanted to highlight that we experience again and again with our prospects. And then when we go in, we try to actually take them away from these four negatives into a more dynamic planning and control tower implementation. Okay. So with that, let's get into the next section. So this is where I'm going to talk about the capabilities as to how do we try to solve this problem, right? And this is where I'll also try to get into the product so that you can get a flavor of how the process is enabled for our customers. Okay, so just keep in mind, the point is not to demo an O9 product. That's not the purpose of this talk at all, right? You are students and practitioners at the end of the day. The point here is for you to get a taste of how decision making happens. Okay, how do we solve for these business problems that I'm talking about? So again, to kind of bring us back to the focus, this is another view of the same, but you can see that there are various planning and execution horizons out here. So you may be doing strategic planning, which is your long range planning, and the CapEx planning that you may be doing. This is where basically you are building your models, right? Your network itself. I'll have open a new DC here, new factory here, that kind of a thing. But then you have your tactical planning, which is your SNOE that you are doing. And this is where master planning and demand forecasting, all of that comes in. This is where you tie in with your annual operational budget, your portfolio management, your commercial planning, your trade promotions planning, etc. Right? All of that comes in here. So you are forecasting these boxes influence each other, right? And then once you have made your annual operational plan, that's what you're trying to follow in your SNOP meetings. So this supply planning, the master planning is the one aspect of it. So in the tactical, it's the master planning that is interacting with the SNOP cycles, and then on a weekly and a daily basis, even hourly basis, if you will, in some cases, we have the SNOE, the execution portion of the SNOP, and the control tower, which is tied to it, obviously at the hip. For us, SNOE and control tower become the same thing, therefore. All right, and then obviously the decisions you are making, you're pushing to the execution layer for the factories to build and the transporters to ship and so on and so forth. This whole thing, right, if you were to take a systemic view, right, at the end of the day, we are trying to solve this problem through software systems. So if you were to take a systemic view of it, this is what that view would look like. Okay, so at the bottom, if you notice, we have data feeds coming in, right? So these data feeds could coming through very traditional systems like your ERP and databases. It could come through your ad hoc systems, which are your spreadsheets, but it can also come in and must come in through your modern systems, which are your IoT hubs, your edge devices, through the various APIs that now exist out there. So essentially what's happening with all of this is we bring it into what we call our enterprise knowledge graph. And you can see that this is, you have your market models, right? You have your demand knowledge models, your supply chain models, you have your whole network there, right? You have your relationships, various relationships between accounts and people and budgets and your customers and all that. All of those details are captured in this. So, so this is like getting data and then converting that data into information, obviously, when you build into, the EKG. And then you are deriving knowledge out of that by populating knowledge models, right? So if you have a supplier and you're getting supplier data, all these POs are coming in, yeah, that's data coming in, the information of the PO coming in. But when you do the analysis and come up with the understanding about that supplier, that this is the reliability of the supplier. He does very well in the summer period, but does very bad during the Christmas period, right? It's very good when the supplier ships from Taiwan, but it's not very good when they start shipping from maybe say Europe or South America or whatever, right? Those are the insights that you want to derive and understand under what conditions the performance is good and versus it's not good. So that basically becomes knowledge nuggets that help you in decision making, right? So on top of it, basically you have all the software that we talk about, what the user interacts with. So this knowledge it is using and presenting it to the user to make automated decisions and manual decisions. And this right-hand side is where the control tower space that we're talking about plays a role. And the left-hand side is the revenue management. And, obviously all of it comes together in the SNOP cycle. Okay. Now I'm going to just take a second here to emphasize the fact that it is very important for you to connect to the edge devices and the IoT systems out there. So this is one example for, so if you were to look at the transportation side, so you have a lot of consolidators out there, right, who provide you tracking information on trucks, on rails, or, the shipping companies themselves. And you want to subscribe to these so that you have the latest and greatest positions of your movement of goods, where they are, and you are able to predict where they would be in the future. Okay, that becomes very, very important, because that is what then you bring in to start constructing and making decisions. So both strategic, static, dynamic, all of that information actually comes in to create this digital brain that we are talking about, right? So, all right. So I want to now again, kind of shift your perspective a bit so that you can start relating to a role, supply chain role, if you will, right? And what are the kind of use cases that these supply chain roles may be able to address. So on the right hand side, you obviously have the sales, that's the most downstream, and on the left hand side you have your suppliers and people who manage those suppliers. So you can think of it that you have a procurement planner or manager, a material manager. Material manager could be, at the procurement side, could be at a DC. You would have logistics planners who could be managing your inbound logistics to outbound logistics to intercompany logistics, right? Intra-company rather logistics. The material manager would be managing the inventory, trying to understand and maintain the positions that you want to have. The production planner obviously is trying to make sure that they are producing according to the promises that the factory is making, to the demands placed on them. You would have global coordinators who understand how each region is interacting with another region, who understand that these are my important customers, class A, class B, class C customers. This is where my goods are, inventory positions are globally placed in the DCs. This is where my manufacturing can happen, or I can outsource to contract manufacturing. These are my standard suppliers or alternate suppliers I can go to. Somebody who has this global coordination position so that they can make intelligent decisions, not siloed decisions, but intelligent decisions by trading off different strategies. Okay. So the idea is that you can read this. I'm not going to spend too much time. We can come back to it. But in general, if you see that there is an alerts layer, right? So you would be trying to figure out the deviations, right? Both in schedule and quantity, and you would be coming up with various kind of prioritizations in this layer, right? So it will try to provide visibility. Visibility would mean that you are trying to understand what the position of a PO is, right? Is it in the request state, or is it committed or recommitment state? Has it been shipped or not? Has it been received or not? Was it partially or fully received? When do I expect it to be? So this is predictive capabilities, that when do I expect it to be received? How reliable is this? All of those things, right? On your STOs, on your inventory, on your production orders, on your actual customer orders, all of these, the visibility, it's going to provide that visibility for you. The plan is looking into the future. It's taking what the input has come in. Then it is looking forward and saying, okay, given that, how do I plan for it? Which means it's projecting that 3 weeks down the road, 3 weeks or 3 months down, the road, I will have a stock out, or I'll have a low stock situation, right? And I need to solve for that. It will say that maybe in 4 weeks from now, I have a demand supportability issue, or I have an immediate demand supportability issue right now. So those are the kind of plans, that it will look forward and try to tell us. Then you have the strategies, which is trying to solve for the issues that have popped up, right? So these are expedite, de-expedite POs, alternate supplier, right? Similarly, expedite, de-expedite STOs. You can source from alternate factories or alternate locations like DCs, right? You could change your inventory policies. You could, in your factory, run extra shifts, right? You could build ahead or build late. You could, conduct demand shaping activities, for example. You may have surplus of one item, you may want to push, and so on and so forth. So those are the various things that you can actually execute in resolution strategies. And we see our customers, literally starts and say that, hey, can you just provide us visibility and alerts? Then can you take us to the next level so that we are actually running a supply demand balance plan? And then can you please help us in becoming more efficient in resolving it automatically and quickly? So we see that crawl, walk, run approach, with our customers. All right. This is all great. Okay. However, let me give you a couple of examples here, and then right after this slide, I'll get into the software so you can see some of these realized in how a user would interact to see the problem, visualize it, and how the software will solve for them, and how will they use that information to make decisions. So just look at demand shaping, for example, right? You may have a demand upside. So a hot order from a customer has come in, but you don't have that item. However, there's a substitute item which you have surplus of. And that is an opportunity for you. Rather than to say the demand is unsatisfied, can you push that substitute item, right? You may have aged inventory, that is inventory at risk. That's what I mean by that. So there's inventory at risk of aging that is sitting in your DCs. And if you make the account executive aware of that, then that account executive can position it with discounts or whatever commercial tactics they want to use with the customers and make a sale there, right? So that's yet another demand shaping activity. So that connection with commercial planning is very important, right? Because if you are seeing that a demand, I'm not seeing demand materialize as fast as say the forecast had predicted, then the commercial department, so to speak, they would say, okay, let me extend the promotion that I'm running. So that will provide an increase in the in the sales. So the supply planning side should be in sync with those decisions. So that therefore that link to the account side, commercial side is very critical. You may have a decision to make whether I cross ship from a DC to satisfy a hot order or not. Or what may be happening is that your orders are materializing, but a little differently from how you had forecasted. And therefore, what's happening is that you have inventory positioned in the wrong places in the network, right? And therefore, you are unable to satisfy these orders. And hence, there is a need to rebalance your network, move supply from the nodes where it's stuck in to the nodes where actually there are demand. So again, suggestions should be made that this is what the rebalancing position should look like, right? Reallocation workflows for order quoting process, promotions, I talked about that. New product introduction, right? If it's not performing as per what you thought, or maybe it's overperforming, in both the cases, whether to expedite to satisfy a demand or not, whether to alternate source it, to build ahead. All of these things basically are the various business use cases that you will come across. So at this point in time, to make it interesting, we've already had around 50 minutes, right? And probably we have 40 more minutes. So let me get into the product a little bit, and then we'll come back to the slide again, okay? So let's do that. So, oops, hold on. So, okay, so let's start from this one. So this is a dashboard, if you will, that I have constructed. So typically what would happen is that you will have role-based dashboards, right? So if you are a customer service representative or an account executive, you may just want to know about the demand alerts and nothing else. Right, and if you are just doing procurements, then you may only want to know about the procurement alerts. These are in-transit alerts, and these are production alerts, which typically a production planner will care about. The inventory alerts, and here we have what we call RO Pulse, which is messaging and some tasks that may be associated and assigned to various people. So these dashboards are configurable by role, right? And you want them to be configurable by role. And I'll show to you in a little while what a manufacturer, maybe a material manager's dashboard may look like, okay? So here you are, let's say, a control tower coordinator or an SNOE governor, so to speak. Then you want to see a global picture, and therefore all of these are there as part of your portfolio here, all right? Now, I see that there are a few demand alerts, and those demand alerts can be many, right? You may have new forecasts, the forecast may have changed, and so on and so forth. But I see that there is a message out here which actually says that there is a demand surge that I need to go and take a look at. So I'm going to go and look at what the issue is, and I see that on this 10th out here, May 10th, I have a issue which is there is a gap so basically red is short, yellow is late typically, and green is it's satisfied. So I'm seeing that there is a particular order which is getting late, and there is a gap, and I actually have a little bit of financial. So I have a 26 quantity short, and I have a financial impact associated with it. So I can come here and take a little bit detailed look. So in this detailed look, I have three sections. The top section is summarizing that it is there is a gap here, right? The final commitment is less than what the asked quantity was, and that's the gap I see out here. And what I also see is that in this network, it tells me where the issue is, okay? And at the bottom, it is actually highlighting that there was this delta, and in the material root cause, it will tell me what the root cause is. Essentially, what it is trying to do is it is saying that, look, I don't have enough inventory, and when I try to procure more inventory from upstream, I don't have enough time to do that, right? There is not enough lead time to go to the IDC and fetch more. So therefore, I have shorted the demand. Now, what the software does is it tries to solve that problem automatically for you. What it does is it says, look, there are other DCs in which there might be material. I want to go and check those locations, but those DCs are not accessible, for everyday decision making. So that's an exceptional decision making which may require an approval, right? So in this particular example, that's how I set it up. You can actually set it up as auto solve also. So here what I have done is we've already run a scenario where I'm calling it a max service scenario, where I went in and I introduced this second lane as a lower priority. So use the first lane as your priority, and the second is as a lower priority. When I do that, then it opens up this, let me expand it a little bit so you can see it better. So what it has done here is it is taking this DC, RDC 10, okay, and it is shipping it RDC 10 to the RDC 9. So I have actually enabled a cross DC shipment as a lower priority route. So it tries to satisfy on this first priority first, but it can't. So it says, okay, I have a material sitting out here in excess material sitting in RDC, and it just takes 1 day of basically shipment. The lead time is 1 day, and here it was 3 days. So therefore it was able to satisfy the demand. Okay, so that's essentially what has happened. So that in very quickly is how the software saw the problem, it highlighted the problem, it solved for it automatically, and it presented the answer to the user to say, okay, here you go, do you want to use it or not? And I'll in a second tell you how the further comparison of scenarios can be done. But before that, I could let me just show you another way of another scenario, so to speak, if you will. So this is a scenario where I have some shortage again coming, and I can go and look at it and see that when I do this, I have this plant, right, which is the capacity. I'm running out of capacity in this plant. That's therefore I am unable to solve for it. That's essentially what is happening. And that basically is reported out here, that there is a, that is basically the quantity that is shorted. And then I can go and look at the capacity, and there is a capacity issue that is highlighted here as well in detail. Okay. Again, here we can actually go to the max service and see how this problem is actually solved. So actually, let me first go back to the let me switch this back to the current working view so I can show you the what's it called, the resource capacity itself. What does it look like? Okay, so I'm going to go here and show you the resource capacity just so that you can see what it looks like. So this is basically what the resource capacity looked like, right? And when I actually go and switch to the Mac service, which is trying to solve for it, what it did was it says that, look, I am going to start consuming flex capacity for you. So it starts using flex capacity. So there was this base 200 units, but it starts using 50 units in flex to try to solve the problem. So that's essentially what it is doing, which essentially it is running an extra shift, if you will. Okay. So in this particular scenario, we allowed for extra shifts to be run to solve for this for the problem. So which is not something regularly that you would have done, but they're saying, okay, if you were to run an extra shift, this is how I will solve the problem, and this is what the impact would look like. So that's essentially the just another way of solving the same problem. If you have modeled it such, if those are the levers that you are allowed to pull in your supply chain to solve for those problems. Okay. Here is another example. This is a resource issue. So this is basically, a line went down. So there's an unscheduled maintenance. Therefore, that is happening. So you can get to the resource here, so to speak, right? And you can see that on this day, suddenly the line went down. The blue line, the capacity is gone down to 0. And the red shows that this is what you are short by. Now, you can actually look at the demand pegging. That means this is the demand for 106 units. This was the order number. So this is basically the constrained amount for this demand. You can, sure enough, go to the supportability and understand, where the impact is, the amount of the impact, and you can get to the details and literally understand that how your supply chain situation looks like here, right? So you can see that it is actually going to this plant, right? So if I was to explain, this is plant number 2, where the constraint is where the line had gone down. Now, if I was to, look at my auto solve, so the auto solve is saying that, well, you know what? I am opening up, allowing you to manufacture this particular order in another plant number 3. And that decision, I opened up and it was able to go to the other plant and therefore solve everything on time. And you can see that, the quantity is satisfied on time now. All right. Now, the very same, I can actually solve in a little different way as well. So this is, again, there are various options that you can choose to solve in a typical supply chain. You will have your preferred way to solve because of operational issues, but you can also add the cost aspect of it, and you want to execute to the most cost efficient manner as well, right? So let me go to the similar situation here, right? So I'm going to go to the supportability page and show you that there is no build ahead, so to speak, allowed to solve for this issue. However, in the Mac service, there is a build ahead. That means I am allowed to go and build ahead by 3 days. So when I go back here, you will see that now my plan, Mac service plan, is using resource capacity, but it is no longer capped. It's no longer, not building just in time. It is saying I can build a little ahead in time. So let me do this. Let me compare. I'm going to compare the 2 scenarios. The current working view will be for you. And so let's get the other one, which is current working view. And if I say compare, you should have, so this green one was the current working view, right? This is the situation where everything went down, the capacity has gone down, but you are not allowed to build ahead at all. And then the max service is this, okay, I will build ahead. That means I'm not just going to produce just in time. And you can see that using the max service view, it is able to solve for that problem. So this is kind of a couple of use cases, so to speak, that using which you can solve. Let me actually very quickly show you just another one so that you get a taste of how we work with our partners. You remember I was talking about ETAs coming from companies like Project 44, 4Kites, Shipio. So here is a case where I have a shipment, okay, that is coming from, it's supposed to have arrived in Atlanta, but it is actually late, all right? So let me actually show that to you again. So this is the lane. Basically, it was coming from Roanoke to Atlanta, and ultimately it is going to Birmingham. But in its first leg of the journey itself, it is a little late. So I can actually go and, go to a partner of ours, 4Kites, which is tracking the shipment, and they actually tell that it is 14 hours, 23 minutes late, so approximately 1 day late. And therefore, it's, and this is where it is stuck. So I can actually go ahead and look at that. I can then go into our the in-transits view, which describes the same result to me that I was expecting it on 20th. It's coming on 6/21. I have a high. It's a negative change, and I have a high prediction that it is going wrong. The reason seems to be weather or other reason, but most, the highest factor is the weather. And I see that in the past, in that lane, weather indeed has been a big issue for me. So if that is the case, I have high confidence on what I received from my partner, and I can come here and I can look at the issue and I see there is an immediate impact. And by checking with my customer at Birmingham, they say that, no, man, I need to satisfy this order. It's a very important relationship order for me. I can then go ahead and look at the same like we have done, and I see there is no way for me to get it built or shipped from the factory itself, because we have hit the plan constraint, as in like the lead time constraint. So, but I do detect that there is this direct shipment from Roanoke that I can make to Birmingham. Okay, so if I was to turn the lead time, so you will see that there is a lead time of 1 here. So there's a lead time of 1. In 1 day I can ship, whereas here it was 1 + 1, so it was 2 days. So I can probably still make a direct shipment and satisfy this order. And this is what I do in my auto solve, if you will, that I open up that lane and explore that lane, and I satisfy that order on time. So you can see that the order is satisfied on 6/21, which was the ask day. So all my units are satisfied. So this is a very quick example again, of how the resolution can happen. So I have other workflows, but let me see. I have probably 6 more minutes before we should open it up for questions, right? So I'm not going to go through other workflows, but you can have I had a collaboration workflow wherein, I talk to the supplier and the supplier talks to me through pulse messaging, they approve and all that. So you can do all that as well. And you will, the point being that communication delay, you remember one of the key issues was that information is not coming from partners. How do you break that silo? You open them up for collaboration. You provide them early visibility into your ask, and you also provide them the opportunity to update the information to you. So here a use case would be that I am placing an expedite order on them, and they immediately see it on their dashboard. They react back to it, they accept it, and you can solve problems like that. Okay. Now, we talked about, before I actually, let me very quickly show you a simple dashboard. So this is a dashboard for, if you will, if I'm a material manager, right, and I come in, what would my dashboard look like, right? I just showed you a dashboard with everything in it, the demand and the supply and, everything. So this is a dashboard where I am concerned about my POs. So I come in and look at my POs, and I am understanding that these POs are in play. I immediately come to know that I filtered according to the criticality, and therefore these are the POs that I should focus on. And then when I expand this, my criticality matrix here, it tells me that O9 is saying that it has got very low confidence in the on-time delivery of these. And this one, there is in full, O9 has low confidence on the in full delivery of this. So if I was to focus on, say, this guy, right, I can actually see it's 3 days late, and then I can see the date on here that this is my O9 prediction date. And this is where you have your machine learning and other algorithms kicking in. So you are analyzing the situation, various factors and events that are surrounding it. And based on that, you are coming up with your estimates here. And then it is also telling you it will be a stock out situation on the commit date, and it is even out of stock today. So it is telling you that. And, it will tell you about lead time, and you can do, second guess your lead time. It will tell you about whether it is single source or not, what goods are getting affected. You can do the same for, your in full prediction, if you will, a very, very similar aspect. You can execute to it. And the key here is that, you can actually go and understand why things happen the way they are immediately, right? So this is a milestone model. It is saying that the original commit was for 1200. Then in the last cycle, it was still 1200, but today it came down to 1000, right? So they kept the date the same, but they reduced the commitment. So essentially, it's telling you what the original ask was, what the last positions were, and now things have changed, and they are trending down. That's what this downward arrow is saying from the last cycle, right? You could also actually go ahead and execute 2 actions. So this is a supply expedite workflow that you could actually go down to, and you can expedite it according to what your communication and interaction with that supplier would be. There are other workflows, like you could do inventory rebalancing and things like that. I'm not going to get into that, just to give you a flavor of how a day in a life might look like. Okay. And closing, after this, I'll get back to my PowerPoint and close out. You can have a SNOE dashboard also, right? So that is very important, where you're tracking various metrics. And in this case, I am tracking what's it called, the alert count metric and the OTIF, on time in full metric, if you will. So the green is my base plan, and then the purple here is saying that the automated decisions that I had made, the alerts went down from here to here, right? So I closed on, I made my plan better, so to speak. So this is the past, and this is the future. So this is past performance, how it looked like, and this is how the future performance is looking like, right? So these are the base plan, and this is the decision that I am auto-resolving and recommending, right? This purple was the published one. Here, this is future, so there's the proposal, right? At the bottom, I'm giving a little bit more detail on it with respect to the customer and all, and I'm showing the lost sales and the alert count and the gross margin, right? And similarly on the OTIF side, that I'm showing, of the past performance, and you should, hopefully your performance is better, and therefore here the purple lines are, you have made decisions, and therefore you are doing better than the base plan. And the brown lines is the proposal that you're making, that this is how you should solve it, and you can see it's better than the green lines. And at the bottom again, this is the plan. This is forward looking. This post game was backward looking, and the plan is forward looking. And actually, if you were to just look at, similarly, we would have supply alerts, by the way. Not going to go there because of time. But if you look at some of the details, it will actually tell you that what kind of manual or automated resolution there was, right? And if you look at the resolution summary, here were the list of orders that were getting shorted or lated. And we proposed an alternate DC to solve these, alternate supplier for the raw material to solve these. We proposed a BOM substitution here. We proposed an expedite here. We used flex capacity to solve these issues. And this is where we did some demand shaping by proposing an end item substitution. So you can see that these are the various decisions that were made and got approved and published. All right. So this is, in a nutshell, how how the software system interacts with users to enable the sales and operations execution process via the control tower. I hope this little demo that I had brought it to reality as to how people execute through various things. All right. Because you guys are students, grad students and all, I wanted to talk about a little bit of the technology that enables this stuff. So this is a summary slide. So the first bullet point I'm talking about is sensing, right? So you are sensing supply, material, and capacity disruptions. So this is where your IoT integrations come in very well, right? So I already gave you a demo in which I showed 4 kites and Project 44. So those are IoT consolidators, if you will, right? You can also connect to factories and understand that there is an expected failure of a machine or a line that can happen, right? So this is where you are predicting where you are, monitoring where you are and predicting how you will be, right? And you are therefore trying to come up with a confidence on time in full performance. Demand sensing is important because social news, events, and weather, though that's the SNOE, so to speak, right? And the industry-specific sensing leads, that's very important. People, because the social news, etc., are hyped so much, people forget that industry-specific leads are so important, right? So you must understand who your customers are and who your customers' customers are, because that's where you can actually sense how your demand is going to change. Then you must understand the customer behavior as well. That this is a nervous customer. He or she places an order and then cancels it, or they wait till the end of the quarter, the hockey stick curve, so to speak, to place orders. One should understand what to expect from a customer when you're sensing demand. Streaming and incremental net change push is very important. This is an integration perspective, right? So I don't want to receive, data in a batch mode. That's siloed. That's latency. I want to receive it as things change. You've placed an order, tell me you have placed an order. You've changed your order, tell me you have changed the order. If you have put a commit, tell me what you have committed to. You have recommitted, immediately tell me that you have recommitted. You are about to ship, tell me. You have shipped, tell me. It's on the route, you tell me. You've received, you've reached, you have unloaded. Tell me at each step, right? It's the order has been released in the factory, it's waiting, it is queued, it's put. I want to know about it, because that's where I can then understand, provide visibility, and build machine learning models to predict things. Then we have LP and heuristic solvers to do end-to-end planning. I've run out of time, otherwise I would have talked about it. So both are good. LP is good in decision making, capacity assignments, allocation assignments, and so on and so forth. And heuristic solvers, order by order solvers, are extremely efficient to make fast decisions and decisions that are understandable by the planner. Okay. Then we have multiple what we call micro solvers to automate decision making. So these are like stand-ins, if you will, for the planners within the software system. So you could automate your approvals. You could update your parameters. You could do incremental solves to mitigate disruptions. You could propose inventory rebalancing or aging inventory substitutions. All of these things are micro solvers that are working on behalf of the planner, already coming up with resolution strategies, presenting to the planners that, hey, think about doing this, or I've already made these decisions, FYI for you, right? That's basically what the technology is enabling decision making. One final thing, that as you see that this is not just about a planner, it is about all roles. This is about the executive. This is about the director. This is about the planner, the operations guy, the sales guy. It's about everything, everybody, right? It's not just about one individual planner who's living and breathing tables and graphs. No, it is at all levels of business decision making. So that's the whole point. The word planner, we are changing the meaning of it. A planner is now a business decision maker. Okay, that's basically what we want the planner to be, because that's what the company exists for. All right. I think I will call it. I'll stop here because I want discussions to happen. There is enough value prop that Umesh had covered in the last section. I would simply call out that the overall value prop for $1 billion company, I think so, the execution side of it is around 20%, the impact. So the control tower can very easily provide 20% value, on that, of that. And we have examples of this stuff, but I think so it's time for question answers. Let's do that.
Great. Thank you very much, Ripu, Daman. Let's see. So we have a few questions, and some of the questions came early on in the presentation. So I think they may have been answered by now. But maybe we'll start with Miguel's questions and kind of turn it back on him in a way. So first, Miguel, you obviously saw some potential impact of the 09 solution on the bullwhip effect. So maybe we'll ask you first. How do you think that the 09 solution could impact the bullwhip effect?
Hello, yeah, very nice presentation, by the way. Awesome what you guys are doing with the control tower, all of your software. I've never seen something like this before, and I'm very happy that this exists. And I would very like much to research on this and get more insights on how you do things. I congratulate you, because this is everything looks very smart what you are doing. 20% on the revenue side, that tells everything. You don't even need to get into the details. I completely understand now. Like, I made some questions, but now you answered like every one of them. Just about curiosity, like for the bullwhip effect, of course, if you have all the end-to-end connected with all your suppliers and all your consumers, this would never happen. Like, if you get access to their forecast, then you just know they're going to have huge increases in the demand, but you know exactly how much, so you don't need to just start placing bigger orders all the way around, but all the way to your supplier, you're going to know which is the exact amount you need to make to meet this increasing demand they are going to have, without like this completely eliminates the bullwhip effect if you do it like properly. Is that correct, Ripu?
That's correct, Miguel, and thank you for the kind words. Yes, you are absolutely right. For exactly the same reasons that you mentioned, that bullwhip effect gets minimized because of that. Yeah.
Okay. Yeah, just by curiosity, I do have two questions, like because like the technical stuff, like you answered already, but I just wanted to know if for these scenarios that you analyze, like the future, how it's gonna react the system after the decisions you make. I just want to know, do you use a simulation in any way, or just like analytics? And the other question would be if you've explored virtual reality for visualization of the control tower, maybe.
So what we call is the simulation that you are saying. It's in a different way, but we call it a what if plan, right? So in the what if plan, the opportunity, there are multiple ways to look at it. Now, the ones that I presented to you was that I have changed the certain things in the planning decisions, right? So I have opened up expedite paths. And therefore, I'm able to run a what-if simulation there, if you will, to see that what would that plan look like if I was to use those expedite paths, whether they are alternate factories, alternate resources, DC, cross DC lanes, and so on and so forth. But another way to look at it is that I can set up what we call the left goalpost and the right goalpost scenarios. So what are those? Those are, if you will, the least likely and the most optimistic scenarios, right? So those kind of things. That what if my demand is 20% more than what I thought it would be? can I run, a simulation, a scenario, if you will, for that, versus what if my demand is 80% of what it is? What that helps us do is it helps us understand the stability of the plan, if you will, helps us be prepared for the upside or the downside. And so therefore you have playbooks ready that if that's what is going to materialize, these are the actions that I would try to take, right? Now I must say that in the execution horizon, right, the way the control tower lives in, the opportunity to run LGP and right goalpost and left goalpost is because of the time constraints, it's less. You can always run and see, but it's got a lot more value in the master planning cycle, right? So on a weekly basis, when you run that, you are already prepared for it, and then in the execution cycles, you can make decisions accordingly, right? Did I
Yeah, that
answer your
was great.
question again?
Thank you. Yeah, that one. Have you explored VR? I think this would look awesome on a virtual environment, like, and it also opens the door for collaboration. The exploit of virtual reality. Have you considered it like to integrate it somehow in this control tower concept you have?
I'm sorry, I didn't quite get that question, Miguel. Could you repeat it, please?
I want to know if you have explored the option of using virtual reality for showcasing the control tower, like giving the decision maker like a virtual environment in which he has all of these screens and he can like look at the graphs and maybe manipulate them with his hands, like something like this.
Yeah, this is very nice, actually. I often dream about it, Miguel. But we will get there. We will get there as those paradigms become what's it called, more prevalent. Today, there is not a single planner who would like to solve their problems in virtual reality. But let me tell you what, the graph widget that I showed you, that graph widget, if I was to zoom out, it will start showing you the global picture, right? Literally planet Earth, so to speak, right? So that you can see the overall view. And as I start zooming in to the network view that you saw and further zoom in, it can actually go to a live video feed in a factory or a DC or on a truck. So we have the capability to do that. That is how we conceived it. So we want our users to use those capabilities. The users are, we hopefully they will slowly get there, but the capabilities are there.
Okay. Thank you,
Thank you very much.
Miguel. Move on to Harini. Ask a couple of questions regarding the scope or scale ability of the tools. I'll kind of bundle her questions together, so Ripu, Daman, you can answer them together. One is the tool appropriate for contract manufacturing, and then in terms of another dimension of scale, is it focused on single product planning and collaboration, or can it be used to plan a whole portfolio of products?
Yeah, these are very good questions again. So the scale of control tower is both at the detailed and the aggregate levels. So how's that? Now, when we manufacture something or we move something and we satisfy an order, that's at its most detailed level, right? Because the order is placed for an item X, and then you're moving the item X to the DC to actually make it satisfied. You are manufacturing that item X at a plant, then you are procuring the materials for that item X, right? And unless I have modeled it at that level, I will not really know what the true constraints are from an execution perspective. Now, the decision making, however, can happen at that product level, or it can happen at aggregate levels also, right? So for example, if I was a VP and I am looking for approvals, I may want to actually just focus on the product line or the product category, as the case might be. And my decision is that this product line has to make so much of revenue in sales, and that's the most important metric for it. And if I am being offered the opportunity to spend some expedite dollars to meet that objective, I'm going to approve all that has been asked off of me for that product line because it's very critical. But I may not give approvals to another product line, which for whatever reasons has low margins, and therefore I don't want to sacrifice the margins to achieve revenue there. So the decision making depends upon the role, what role you are in, and you can make decisions at an aggregate level, while the representation of it is absolutely at the detail level. Okay, you can obviously make decisions at the detail level. That is given. The second question is, how does this tool deal with contract manufacturers? So contract manufacturers, actually, there are multiple flavors of contract manufacturers, but if you will, we represent the contract manufacturer's location in the software itself. Depending upon how much detail and insight the manufacturer is giving us, we will model that detail, right? So I have customers who say that none of my business, the contract manufacturer said that they will make 10,000 units a week and I'm going to hold them responsible for it. So then what we do is that in our system, we will represent it as 10,000 units of capacity, right? And in our integration with the contract manufacturer to get the capacity and the progress of the various WIPs, etc., is then abstracted to that level. Whereas there are other customers who say, yeah, my contract manufacturer is there, but we do shadow planning, which essentially means that there are these product planners shadow product planners who want to know this is how this line is performing, this is how this machine is performing, while they have no direct control over doing that because that's the contract manufacturer's job. They are providing very close scrutiny and oversight, in which case our integration with contract manufacturer would say, give me the line level details, give me the line level capacities, and so on and so forth. So it totally depends upon how our customer wants to model what their relationship with the contract manufacturer is. Okay.
Great, thank you. And a final question. We may have addressed this a bit toward the end, but maybe expand on it a bit. What technology or process does the tool use to monitor KPIs and detect disruptions in real time?
Yeah, so I think I did answer this question. So to monitor real-life disruptions, so we have, obviously, ours is a very modern SaaS-based solution. We have API integration, so you can do streaming data integration with IoT data and all other kinds of data feeds that are possible. We have Hadoop Hive integration at the back end, so it's very scalable. So the example I gave you, the ETAs are coming in, they track the shipments, how the loads are moving, and we receive that data. So that's how we are, we can detect things. We also can have sensing algorithms, right, which can sense events that are happening and therefore propose that probably these events are going to happen. So therefore, to sense, you need to have data feed coming in, like you have weather data feed coming in, for example, or you have social feed coming in, or you have some other dedicated feeds that come in, which help you sense how the pictures are changing. So those capabilities can be built in. Then on the monitoring of KPIs, if you will, the monitoring of KPIs is essentially once all of this data is in there and we already have the past and the future plan, it's just a matter of constructing those KPIs. So we provide a lot of KPIs out of the box, and we keep on computing those continuously.
Great. Well, thank you. And I see we're right on time here. Was there something just popped up? No? Okay. So again, Ripu, Daman, thank you very much, and thank you, O9 Solutions. For everyone, you see on the screen now the next two sessions. Next one focused on inventory optimization, March 24th. And please click on the link or go to the website to get your invite to it. Thank you all, and have a good day.
Thank you.
Thank you for the opportunity. Thanks.